is all you need. That's the name of this paper, famous paper that Google released by 2017. Attention is all you need. And after that, it became a kind of a style. Now, when a computer scientist, for example, they release a paper, and memory is very important. They say memory is all you need. So attention is all you need. So that's, but why this paper is very important. I don't want to talk about the details, but I just wanted to say what is this attention in large language model. And what is large language model is what that drives ChatGPT and any other kind of AI model these days that they can talk, they can guess next words or next image or next music or whatever. They're coming from all this kind of interesting large language model, which inside them there is the architect, we call it transformer. So how can I explain in a way to not be in a technical way, but in a way that everyone can get a grasp of it? Maybe I can do this. When you are, imagine you're in a party, you go to a place, a lot of people, they're working, you have no idea about them, there are a lot of them, but then you have a question. For example, you want to know who was historic questions about South America, for example. And then you want to ask from people. You have these questions. What are you going to do? You're going to imagine, hypothetically. You start to ask the question, who knows about this? So what's going to happen, everybody carries some information about the question. Some people maybe zero, I don't know. Some people, they have doubt a little bit. Some people, they have details information. If you want to make sure that you grasp the correct answer, you're going to go and talk with every single one of them. It's not efficient, but you do that. You communicate with every single one of them. Imagine there are 1,000 people. So, and imagine this is a hypothetical case. It's not really happening in real life. But you talk with every thousands of them. What do you have about this question? So you take a part of their value. There's a value in everybody. There's a value. For example, if your knowledge certainty is 20%, consider 20% of your knowledge. Value is important. If you look at the number, is how much you count on that person information. If you are a history teacher, perhaps I put 0.8 a score to your knowledge. And then I get an average of everybody knowledge and I bring it down here. I write down, okay, this gal said this, guy said this, times by 80%, times by 1%, times by 0, he doesn't know anything. I don't want to just, rely on that. So you bring down all the informations. Basically, you attending to everybody and ask their attention to you. And then you collect all those informations and bring it back and then merge it and then look at it. And then you have initial questions, right, about that kind of story. Then now you have very interesting knowledge. You have the knowledge of everybody in the room because you got it. So there is a question, we call it query, the query that you raise, the question that you raise. And then everyone in the room has a name, I don't know, just as a number even. You just assign numbers. That's a key. You go to every one of them, you tell them this is my question. So you refer to everyone. Everyone has identity. It's not like if I tell you we, she's we. If I say Saraf, it's not like gonna get confused. Are you Saraf? I know her name is Saraf, so it's easy to address. And everyone has a value. Then all these three concepts, query, the questions that I put it out, every one of you is a key for information, is key to unlock my ignorance about the historical question, and you carry forward the value. And I have to figure out that one. So when I come up with all those numbers, no numbers are important, 0.8, 0.2, 0.6, or whatever, and then I apply them to the answer that you get me, then I can say that I know the answer. And if the answer is wrong, okay, let it be wrong. I already talked with 1,000 people. Well, what can goes wrong? Huh? If you have the access to 1,000 people, in that way you can do that. So this is one way. You may say that maybe there are other ways to attend to people. Maybe we don't need to do that. What if I attend to every 5%? Every 5. So then instead of the 1,000, you're gonna be 1,000 divided by 5, 200. So 200 people, maybe 200. You are right. You may save the time, but you can't be sure that the information you get from 200 people is exactly equal by the information that you get from the 1,000 people. But 1,000 is everything. So this sort of, now you get this analogy. I want to bring it back to, for example, text. Now imagine we have this text. We have this. When you go to the ChatGPT, you write something and then questions and press enter. And then you get the GPT start to guess the next token, and you see the tokens are coming, right? So at every step that you see a new token, for GPT does not exist the future. It just exists that token. I guess the token, and then again next token, again the next token. It's a very high computational process. It means generate one token and then look at this new token and all these kind of things and then create the next one. It's not like that it already created and then it start to put it there. It create one by one. Now I want to bring it to this concept of the attention. What happened in this paper, attention is all you need. They come up with a way which is much efficient and faster than previous models and approaches in machine learning to let AI understand the concept and context. For example, that's what this attention does. We already have, let's say, a long message, a long text. Let's just say this text is come from a math book, come from a science book, come from a business article, whatever. But there are a lot of words in it, right? From the beginning till now. Then you want to guess the next token. Looks like you are going to ask a questions in that party, but who are members of the party? Every word. So look at every word as a person in the party. And what is your question is not that historical question. What should be the next token? So every word has something to say. For example, if I tell you that for example, let's pick up a term like this. You have no idea. It was bloody delicious. You have no idea. It was a bloody experience in my life. The first one, all is positive. You know, that bloody is positive. Bloody delicious. So what do you guess? Huh? It should be what?
Food.
Yes, can. What else?
It's food naturally.
Food is very, so
like some dessert.
Some dessert or bloody drinks or so you come up. You see what's happened. That delicious suddenly move the bloody to go somewhere else. Make it far from where we know about the bloody. You look at it in a different way. So you see that one word has this ability to make change in the way that other words work. And when you have all these words, every single one of the word has an impact. Maybe very little, maybe very high. To guess what is the next word. So that's very important. That means somehow it should be a mechanism to incorporate all the words to a calculation to come up with the next word. Remember in the party, if you are history teachers, I give you more score, right? So for example, if you are propositional, the, maybe I look at you a little bit less important because a or and, maybe they don't do that much of it. But if, for example, bloody, I look at it very important. If the subject, I look at it very important. But the interesting thing about it is, we don't teach AI this is subject or whatever. We don't teach anything. We just produce a procedure that AI look at all the numbers. Initially, AI start to give them random weight. It doesn't matter. It doesn't matter really this. Then use all of them, calculate all those attend to all the words before, put them in a kind of calculation and a complicated process that then this process produce something very interesting. For example, every word, every language has vocabulary. It's a limit. For example, let's say English maybe has 50,000 vocabulary. And then the next token, the output of this model is like this. For every 50,000 vocabulary, produce a number from 0 to 1, which is the probability of that number should be the next. 50,000 for each one of them. And then it pick up the highest one. The highest probability. And then bring it in to put it there. And then again, does the whole things. But it's a lot of things, but it's happened very fast, right? That's why it is actually. That's why a lot of researchers.
Every single word you have to guess the next word.
The next word, and this is what brain does. Every single thing that you do in your life is just guessing the next things, with a lot of heavy process. But the interesting thing that when they start to do the training, the machine doesn't know anything about it. They put a big word, they bring a lot of text, whatever text over the internet. So they, for example, take a chunk of it. Let's say 100 words, and then there's 101 next word. So what is happening? They fit to this neural network, this text, and then the neural network start to make a guess. At beginning, because it's just random, the guess is not good because it's random. It's just it looks like I go to the party, but I don't ask what is your background. I don't ask if you're a history teacher or not. I just ask and just collect all the answers, and I don't care if it's right or not. Imagine you go to the back to the party again, you ask the questions from everybody, but you don't care if the answer is correct or wrong. So when you back those numbers that you assign, it's not 0.8, it's not 0.3, all is the same. Just 1, 1, 1, 1, 1, 1. You imagine that whatever they say is right. So you put it there, and then you write an essay, you write a conclusion, and then you give it to historian says it's wrong. And then you back again, an historian give you comments, wrong because of this and that, and you back and look at everybody answers, oh, this answer is close, oh, this answer is the reason I made a mistakes. You start to play around, okay, I don't give you full attention. I'll give you half attention this time. And then again, you repeat this, and then you create a new essay, and you bring it to that master. Master says, it's getting better, but there's still this part is wrong. You're back again, look at everybody answer, and then you say, so no, I don't want to give you 0.5. I want to give you even lesser, 0.3. But wow, your answer is very close to what master said. So there's something in you I don't know. Maybe you watch YouTube history a lot, I don't care. But there is really something about that person. That's why the correct answers came. So I give more weight to that person. And I keep doing this. After a while, I have a proper understanding of who knows his story, who doesn't know his story, without becoming a master of his story. Just with the help of a person to tell me how answer is wrong. And then after a while, when I do this, if you ask any new questions within the same context of the story, then I know where to go. And I know how to, and my answers surprisingly will be very correct. I became the master itself. Now I am the master. If I can continue this literally in a time, if I can continue this for 20 years of my life, okay, I will be the master of his story, right? Because I can ask all the questions, I go and I check, and after a while I know everything. Because I know every single 1,000 people in the party, and everyone, I know how much knows about this and that, and then the questions comes. So in computer, this 20 years can be done in few hours. That's the secret in the AI. In computers can be done in we can have million of them. You know, if you can let it, for example, GPT continue for, if I'm not wrong, for 10 months, 6 months, different models for 1 year. 1 year training means it's keep busy training, and the input data and then do that. This is the foundation of how this model, without instructing them what is grammar, what is language, what is the meaning, they grasp the concept. This is very similar to the way that you learn, this is cat, this is dog, this is bird. No one come and give you lecture in biology at age 5 that bird is this and that. You just look at this, you say bird, your dad says, no, this is not bird, this is your mommy. Oh, okay. Oh, this is cat, no, this is not cat, this is your uncle. Oh, this is cow, oh yeah, that one is cow, you're right. So you get these feedbacks, continue. That's why we're so vulnerable to parents they can screw up everything, and then we're gonna be some concerned adult and always back to the childhood time because we do that training. This is basically this is a process of machine learning. Okay, and back to that attention. Before this 2017, common models to let computer learn human language, they had this issue that you couldn't run them in long sequences. And when you want to read the internet, there are a lot of text. There are long sequences, there are long sentences, paragraph and text. They had this kind of goldfish issue that they could forget immediately. So they could remember just like the last 10 words, the last 1,000 words. And they come up with this very interesting approach, which is much faster. And it can be run parallel. That means if you have one, you don't need to have too many computers. One computer can run many of them in parallel using the GPU and make it super fast. And then when they started to do this 2019, OpenAI, Elon Musk put the money, and then what they did, they started to say, okay, we came up with this mathematical solution that if the size of the data is really big, something beautiful will happen. So they started the Ep.1. They were thinking that much data is good, but something came out interesting, but not that very kind of phenomenal. And they moved to the GPT-2. Then the outcome was much better, but not like what you say. Wow, everyone knows about it. This is 2020. You didn't know anything about it because that wasn't like kind of phenomenal things. Then they started to train it finally with a huge amount of the internet data, and GPT-3 came out, and then suddenly even themselves, intelligent emerged. You see, they did almost the same thing. It's not like for GPT-3 they did something else. It's transformers, but they just put more data, more data. That is the very important point in the history of the AI. That everybody now knows that more AI, you're going to get more intelligent, more data, and not more intelligent. You will be surprised. Suddenly, awareness come out of it. I know I exist. And even who knows about the human consciousness is emerging pattern. Emerging pattern means those patterns that nobody planned them. They just emerge. For example, a one atom molecule of hydrogen doesn't have any idea about the weather, climate, air pollutions and tornado and that kind of things. But when they all connected with all oxygens all together, they suddenly come up with something that they didn't know it. That means the particles, they had no idea about the outcome. But when they connect together, they build a big system, complex system, suddenly patterns emerge. And this is very interesting. This that you can talk with GPT and understand emerged. It wasn't, we know that you're creating a model which is good to guess the next word. But we didn't know that this turned me to a master of history. And I can lecture about this story and I can be so accurate. So these things, very beautiful. Looks like when you raise a child, you don't know, new things come out of the child. And then you say, you didn't get this from me, you got it from your dad. Or you didn't get it from me, you got it from somewhere else. You know, this is something that's happening. So the takeaway here is attention. So let's summarize it. This is the summarization of what we just discussed right now. I gave you an example of a party. You go to a party, you have historic questions, and you have no idea about these people. So what are you going to do? You're going to go and try to ask every single one of them and write down the answer. And then you start to consider, at first, if you know nothing about this person, is it valid or creditable or whatever, so just look at all the answers equally. And then combine them and write an essay, and you go give it to a master of history, and the master of history tell you that these are mistakes, these are good things, give you a list of kind of comments. You back again, and you check with all the answers, and you see, oh yeah, this is, and then you start to give them different attention. I give you less attention, I give you more attention, I give you this and that. And then you, again, bring them and write down, and then you show to the master of the story, you get new comments, and then you back with the new questions with those comments, and then you apply, and then you continue doing this, and after a while you're a master of the story. And to do that, you attend to every single 1,000 people. And then from here we jump to natural language processing. We said that imagine now we have 100 words, and you want to guess the word 101. So what are you going to do? That you look at all the words, because all the words can impact the next word, like a bloody delicious or bloody difficult. Okay, so that's the two different things. And you have no, and you close your eyes. Imagine this is Chinese even. For example, I don't know Chinese language, or a language you don't know at all. It doesn't matter. That's the interesting things. You just, let's call them word. It doesn't matter, alien language. As long as you have the data of it, you do have enough data for that particular language, then you can start to put it and then guess, and then you have a machine that understands. So that's why some people criticize, they say that, yeah, GPT is like human, but doesn't know what it says, just like a kind of monkey and bird. But then people say that we are like that also. You think whatever I say, told you, just come out of myself? No, I read the articles and I'm a computer scientist, so I do this and that. So everything is connected, and there is a random. The interesting thing is, remember that when I told you that they look at all the 100 words, and then for the final word, what is the output of this AI is creating probability for all English words. For example, if you're in English, the 50,000 words, and that is a probability. For example, 10% should be this, 60% the next word is this, 0%, 1%. So you have all of them, and you pick up the highest one. The one is most likely one, and then you bring it and then doing this. When they start to do that, they did one very interesting thing. They figured out if they always bring the highest probability here, after a while the output become boring. Output become repeatable. So what they did, they pick up top 10, for example, and randomly they choose one of them. So not always do your best. Okay?
So random top 10.
Yeah, random top 10, for example. And now when you work with them, you have this capability to play with those parameters, not in the chat GPT, but in a programming way, you can control that randomness. If the randomness is high, they call it more creative. If the randomness is 0, you say, no, this is exact. For example, you give the customer or website contents or product brochures, you don't want AI to be creative. You want AI just exactly refer to the one that is the highest one. That's the point. But you want to create poetry and this and that, you need the creativity. So this is about the attention. But from the day it is published, and there are many other people, this attention is time consuming. It produces a lot of CO2. So what they're trying to do, there are a lot of interesting algorithms coming out to make this process very more efficient. There are different, for example, some people, they figured out, you don't need to attend to every single word. So the initial words are more important, the middle words are more important. They come up with a really interesting heuristic way to make this attention looking all the, basically means don't go and talk with all the 1,000 people. To try to see, you try to look, he doesn't look, she doesn't look good, or this, or looks like nosy story or not. But you may be wrong, but that kind of heuristic. So this is about transformers and how we train these models, and a little bit of the attention about it. This is the concept. Attention is all you
Very
need.
nice.
Any question?
No, I think it's very clear.
Very clear. Any question? So that means you guys go and build a new model for me till end of today.